Titan, the largest moon of Saturn, is not just another frozen rock in space, it's one of the most captivating enigmas in our solar system. It's the only place, aside from Earth, where we found stable liquids on the surface. But here's the twist. Those lakes and seas are not filled with water. They're filled with liquid methane and ethane hydrocarbons that would vanish in seconds on Earth. Yet on Titan, they flow freely, carving rivers, forming clouds, and falling as rain. In this strange, freezing world, nature repeats Earth's patterns, but with ingredients from an alien script. Please like and subscribe because this journey will change how you see our place in the universe. Prepare yourselves. We begin. There are places in the universe that whisper to us, not in the language of Earth, but in the raw code of reality, chemistry, light, gravity, silence. Titan is one of those places, a haunting echo of Earth, not in warmth or biology, but in rhythm, in pattern, in soul. It is as if nature herself took the blueprint of our home and rewrote it with ice instead of heat, methane instead of water, and twilight instead of dawn. Orbiting the majestic Saturn, like a ghost caught in amber, Titan is massive for a moon larger than Mercury. Yet it doesn't shine. It shrouds itself in mystery. A golden haze, thick with nitrogen and hydrocarbon particles, wraps its body in secrecy. You cannot see its surface. You must listen with instruments, feel with radar, and imagine with the mind of a poet and a physicist combined. And when you do, you discover something uncanny. Titan has weather, seasons, lakes, rain, evaporation, river deltas, erosion, storms, a cycle fluid, living, evolving. But its waters are not ours. Its rains would kill us. Its oceans would freeze our blood. Methane and ethane flammable on Earth. Liquid on Titan form the beating heart of this alien hydrology. They evaporate in the dim sunlight, rise into clouds, drift across the skies, condense, and fall again, just like water, just like Earth. And yet, utterly unlike anything we know, Cassini, that wandering mechanical eye, saw it first. Orbiting Saturn from 2004 to 2017, it sent back whispers and echoes, radar images, spectral data, gravitational curves, and those whispers became a revelation. Titan is not dead, it is not silent, it is not still, it breathes. Its lakes glisten like obsidian mirrors beneath a sun that barely shines. Its air, thick with nitrogen, holds within it a breathless potential, a medium for weather, for motion, for mystery. This is not a moon caught in stasis. This is a planet-sized experiment in alternate chemistry. Imagine standing on its surface. The sky is golden, heavy, surreal. Shadows stretch in every direction, never quite solid. The pressure around you is higher than Earth's, like standing under the sea. And the cold is so deep it feels eternal, like time itself is frozen. And yet, in that stillness, things move, clouds drift, winds stir dunes. Methane trickles down canyons. Storms brew on the horizon and spill dark rain across frozen stone. Here, the earthbound elements are recast in alien form. Liquid behaves like vapor, ice behaves like rock, fire cannot exist. And still, somehow, the laws of physics write familiar poetry in unfamiliar ink. Titan's surface speaks the language of cycles. Its polar lakes rise and fall with the seasons. Its erosion patterns speak of ancient flows and sudden downpours. Its dunes miles long and hundreds of feet high shift slowly under dense winds, shaped by time and chemistry and patience. And all of this happens in darkness. Sunlight, filtered through thick layers of hydrocarbon haze, never truly reaches the ground. There is no day, no night, only a perpetual golden dusk that never lifts, never brightens, never fades. It is a world where time crawls and light lingers like a forgotten memory. And yet, even in this shadow, there is symmetry. Because Titan, in its frozen, alien way, reminds us of home. It mirrors Earth not in detail, but in design. It whispers, "I too am a world, not dead, not barren, but different, cold instead of warm, methane instead of water, twilight instead of sunlight, but a world nonetheless." The implications are staggering. If the machinery of nature, evaporation, precipitation, erosion, can operate in a completely different chemical regime, then life may not be bound to ours. It may not need water, it may not need light, it may only need pattern, energy, and time. Titan dares us to ask the forbidden question: what if we've been looking for life in the wrong places, in the wrong forms? Because if rivers can flow without water, if clouds can gather without warmth, if a world can breathe without light, then perhaps life itself is not the miracle of Earth, but the inevitability of chemistry. Titan doesn't just suggest this, it embodies it. This is not just a moon. This is a cathedral of alien logic, a monument to cosmic creativity, a stage where the universe writes a different version of the story we thought only Earth could tell. And now, as we descend deeper past the haze, into the methane seas and the cryogenic plains, we are not merely explorers. We are witnesses to the possibility that life, like the cosmos, does not follow a single script. It improvises. There are places in the universe where twilight never dies, where the sun is a ghost and shadows have no origin. On Titan, night and day are meaningless, just gradients of amber light filtered through a sky too thick to reveal the stars. Titan is tidally locked to Saturn. One side always faces the gas giant, caught in eternal gaze. That orbital embrace creates what scientists call terminator zones, regions that never know full daylight nor full night. In these twilight belts, the sky hovers between sleep and wakefulness. It's as if time itself holds its breath. Here, light doesn't guide life. It confuses it. Sunlight, weak and filtered through clouds of complex hydrocarbons, barely reaches the ground. The result is not darkness, but a suspended golden dusk, a soft, dusted glow that turns every mountain into a silhouette and every lake into a pool of liquid shadow. And in this eerie light, something ancient moves. Titan has a climate, a fully functioning atmospheric engine powered not by heat, but by chemistry. The Cassini-Huygens mission confirmed what scientists had long suspected. This moon is dynamic. It evolves, it breathes, and above all, it rains. But what falls from Titan's clouds is not water. It's liquid methane, formed high above in thick clouds that drift across the globe like ghost ships. These clouds condense slowly, accumulating droplets larger and heavier than raindrops on Earth. And when the methane falls, it does so with solemn grace, slow-motion tears descending in the negative 290 degrees Fahrenheit air, drifting gently toward frozen ground. This methane rain doesn't fall often. It waits. It gathers. Then, during seasonal shifts, it breaks loose, sculpting temporary rivers that flow across Titan's icy terrain. These brief floods carve the land, just like water shapes Earth's deserts. Cassini's radar has captured the erosion patterns, clear signs that, at least occasionally, Titan weeps. Its rainfall isn't random. It's woven into long, slow seasons that span over 7 Earth years each. When the southern hemisphere tilts toward the sun, clouds gather, rains come, and lakes swell. As the years pass and the hemispheres reverse, the process begins anew, like some distant clockwork god winding Titan's pulse with deliberate patience. Yet even between rains, Titan doesn't rest. Its winds, though slow due to the moon's dense atmosphere, are still capable of movement. They whisper across the land, shaping towering dunes of frozen organics, dark, wave-like ridges that stretch for hundreds of kilometers. These dunes resemble Earth's deserts, but are formed not of sand, but of tholins, complex organic particles created in the atmosphere and dropped like dust. In these quiet winds and slow rains, Titan reveals its secret: motion without haste, change without heat, life without certainty. The sun, for Titan, is less a source of energy and more a rhythm setter. It flickers behind the clouds. It guides the seasons but never fully arrives. At times, even this meager light disappears not behind a moon but behind Saturn itself. Titan experiences eclipses, unlike anything on Earth. Saturn, an immense gas giant, periodically passes between the Sun and its moon, plunging regions of Titan into an unnatural darkness. These eclipses aren't brief flickers. They can last for hours, and when they do, the local temperature drops sharply, the atmosphere contracts, winds shift, and strange weather phenomena ripple across the surface. There are places on Titan where this twilight is eternal, regions near the terminator line, where the sky never changes. Scientists speculate that in these zones of permanent dusk, the climate may be unusually stable, a rare condition that could, in theory, support life. Not life as we know it, but life that adapts to cold, to darkness, to methane and nitrogen, and slow time. Life that waits, listens, grows in silence. Because despite its alien nature, Titan follows rules, not the rules of Earth, but of the universe. Gravity still holds, chemistry still works, physics still governs the winds and waves. The moon may be strange, but it is not chaotic. It is consistent, predictable, governed by invisible equations that, once understood, might reveal the possibility of biology. This is what makes Titan so profound. It is not an unearthly chaos, but an alternate Earth, a world where nature uses the same grammar but writes a different poem. A place that makes you ask, if methane can rain, if dunes can form, if seasons can pass, what else might emerge under these golden skies? Beneath the methane clouds, Cassini found lakes, vast bodies of liquid hydrocarbons, still and silent, nestled into carved-out basins. Some are so large they rival Earth's Great Lakes. Some even show signs of wave activity, hinting at winds strong enough to stir the surface. Others lie perfectly still, mirrors to a sky that has never known true light. And then there are the storms, immense methane hurricanes that sweep across the poles during equinoxes. These are not frequent, but when they come with force. Lightning may flash, thunder may roll, and on a world where water has no place, the skies still roar. Titan's atmosphere is a lab in the sky, a place where ultraviolet light, cosmic radiation, and extreme cold conspire to synthesize complex organic compounds. Some of those compounds fall as rain, others drift as dust, and others still may become something more. Because what's building on Titan is not just weather, it's potential. Potential for complexity, for chemistry, for life. Not life powered by solar warmth and blue oceans, but by cold methane lakes, seasonal eclipses, and winds that blow in eternal twilight. It is easy to look at Titan and see death, but to look deeper is to see becoming, a slow, frozen becoming. And if you can look beyond the haze, past the metrics and measurements, you might just feel it, the quiet heartbeat of a world that should not be alive, but somehow is. Water built the story of life on Earth, but what if another liquid colder, darker, stranger, could write a different story? One told not in warmth and sunlight, but in the hush of twilight, under a sky soaked in gold and silence? On Earth, water is sacred. It's the solvent of biology, the sculptor of continents, the breath of clouds and rivers and veins. But Titan has none of it, at least not on the surface. Here, methane plays the role water plays on Earth, and it does so with elegance, with patience, with a quiet persistence that rewrites the very idea of habitability. At a temperature of -290 degrees Fahrenheit, -179 degrees Celsius, methane is not a gas. It is a liquid, smooth, flowing, real. It gathers in lakes and seas, fills rivers, forms clouds, and falls as rain. In this distant world, methane is not just present, it is alive in motion, part of a complete planetary system that mirrors Earth's water cycle with chilling precision. This isn't a poetic metaphor, it's a measured fact. Spectrometers and radar systems aboard the Cassini spacecraft traced methane's full cycle: evaporation, condensation, precipitation, runoff, and collection. A cycle eerily Earth-like, except it runs on a flammable substance that could explode in the blink of a match back home. Yet here, methane is not fire. It is life's architecture, a frozen ghost of water's role, a different path through the same cosmic logic. Titan is not dabbling in chaos. It's committed to this chemical ballet. The polar regions host vast seas, some the size of the Caspian Sea, like Kraken Mare, a methane-ethane basin, so vast it might once have been mistaken for an ocean in early scans. These lakes, these seas, they're not theoretical. They were seen, measured, tracked, and mapped. We watched them grow. We watched them shrink. We witnessed the tides of a frozen world. Seasons come slowly to Titan, each one lasting over 7 Earth years, but they leave their mark. The shapes of lakes change. Their shorelines move. The depth of methane reservoirs rises and falls. Over the course of Cassini's mission, scientists observed these seasonal migrations. Titan's climate breathes, just slowly, deliberately, with a tempo measured in decades, not days. But it breathes. Even more haunting are the ancient riverbeds, long scars in Titan's crust where liquid once flowed with force. These aren't cracks or craters. They are evidence of movement, of time. Some flow into deltas, wide fan-shaped regions where liquids spread and pool. Others terminate in silence, perhaps drying before their journey finished. This is more than geology. This is memory. Every canyon carved by methane tells a story. Every delta is a page in Titan's liquid diary. Every frozen tributary is a whisper from a time when something alien was happening here. Methane is not water. It is non-polar. It does not dissolve salts, proteins, or sugars like Earth's oceans do. It is a solvent with strange limitations and stranger possibilities. And yet, it performs the same tasks. It shapes landscapes, it stores energy, it transports matter. This duality forces us to confront a deep question. Is life a matter of specific ingredients or of processes? If Earth's life depends on water, is it because water is essential or simply because it was available? Could methane, in its cold patience, do the same? Could it cradle complexity? Could it become the medium through which molecules learn to dance? Titan dares to answer. Maybe. Its hydrocarbon cycle is not hypothetical. It is visible, measurable, ongoing. We've seen the lakes glisten. We've traced the erosion. We've watched the skies. Titan's methane cycle is not just a mimic of Earth. It is a proof of concept, a demonstration that fluidity, erosion, evaporation, and rain are not bound to Earth's warmth, but to universal physics. On Earth, rain nourishes. On Titan, it sculpts. When it falls, methane gathers into temporary rivers. These streams flow, dig, split. They etch their mark into icy bedrock. Then they vanish, leaving behind dry channels, a reminder that even in a world without life, the forces of change are constant. But Titan isn't static. That's the point. Cassini watched storms rise over its poles, their lightning silent, their rain slow. It watched waves ripple across a sea of methane, gentle, yes, but undeniable. It captured the first alien coastline ever observed. And in those moments, a new kind of map was drawn. Not of continents and nations, but of possibility. This isn't science fiction, it's science. Finally seeing the poetry that has always been there. Titan is a world where the rules still apply, but the materials have changed. Where rivers run, but not with water. Where clouds form, but not from vapor. Where life's architecture might be possible, but not familiar. And that is perhaps the most profound truth of Titan. It does not feel barren, it feels other. Not dead, not asleep, just rewritten. A world with a pulse we're just beginning to hear. A chemistry not alien in hostility, but in invitation. A call to expand our imaginations, to stretch the meaning of habitability beyond the limits of our own experience. If life can exist here, it will not look like us. It will not breathe like us, but it might function, adapt, evolve, because the patterns are present. The rhythms are real. Titan does not promise life. but it promises the conditions that make life thinkable. And in the cold mirror of its methane seas, we don't just see Saturn's reflection. We see Earth's assumptions begin to dissolve. On Earth, rivers are veins, lifelines that carry water, energy, and memory across the land. But what happens when those veins run not with water, but with liquid fire in frozen silence? What happens when a landscape is carved not by heat, but by stillness, patience, and methane? Welcome to Titan, where geology dreams in the language of ghosts. Across Titan's surface stretch intricate webs of channels, valleys, and erosion scars, evidence of rivers that once flowed, or still do, under the slow breath of alien weather. But these are no ordinary rivers. They shimmer with liquid methane and ethane, moving sluggishly across a world where everything is slowed by cold, thick air, and time itself feels reluctant to pass. Cassini's radar peered through the moon's golden haze and revealed a planet-sized tapestry of terrain carved not by earthquakes or lava, but by hydrocarbon erosion. It saw river deltas wide, fanned-out deposits where streams once branched and emptied into lakes. It saw canyons, steep and narrow, etched by persistent flows. It saw dry valleys, empty channels awaiting the next methane rain, perhaps decades away. The ghost of water, rewritten in methane. These rivers speak not just of weather, but of history, a geological memory captured in frozen motion. Titan's surface is a palimpsest of cycles. Storms gather, rain falls, rivers run, lakes fill, and then silence. The flow stops, the terrain waits, and slowly, over years or centuries, the process begins again. Even more profound is what lies between the rivers, the ghostly, rolling plains and dune fields that stretch across Titan's mid-latitudes. Here, Cassini found towering dunes that rival Earth's Sahara. But unlike Earth's sand, Titan's dunes are composed of tholins, solid organic particles, created in the upper atmosphere by sunlight, interacting with methane and nitrogen. These tholins fall from the sky like burnt snow. They coat the landscape in a dark, reddish-brown powder, flexible, fine, unfamiliar, and they move not quickly, but undeniably carried by Titan's dense but gentle winds. Over time, they pile into ridges hundreds of kilometers long and up to 100 meters tall, parallel stripes, ghost lines on a canvas painted in shadows and chemistry. Wind, it turns out, is the silent sculptor of Titan's soul. Even though the winds move slowly, because Titan's atmosphere is thicker than Earth's, the density of that air gives it surprising strength. A whisper here can carry more force than a breeze back home. These winds shift the dunes, reshape the tholins, transport organic dust across vast distances, and from these subtle movements, something beautiful emerges: change. Titan is not frozen in time. It is moving, breathing, evolving, slowly, yes, quietly, always, but unmistakably. One of Cassini's most unexpected discoveries was the presence of hydrocarbon dust devils, dark spiraling storms that rise from the surface like swirling phantoms. These devils dance across the land, carrying fine organic particles with them, dispersing prebiotic compounds from one region to another. Imagine that, a dust devil not made of sand, but of carbon chains, molecular scaffolds, the ingredients of possible life moving through the eternal twilight of a methane world. These aren't just meteorological curiosities, they are transport systems, nature's way of blending Titan's chemistry, of mixing atmospheric alchemy with geological design. And then there are the scars. Impact craters pockmark Titan's crust, but they are rare, too rare, in fact, for a world that's billions of years old. Many of them have faded, blurred by haze, softened by time, filled by methane rain, or buried beneath falling tholins. This suggests something radical. Titan heals, not with tectonic shifts like Earth, nor volcanic floods like Venus, but through atmospheric erosion and organic snowfall. Titan is not just shaped by impacts, it responds to them. Every crater that vanishes is a sign of activity, of motion, of time continuing to pass. Some craters are elongated signs of oblique impacts, possibly from Saturn's own shepherd moons. Others appear random evidence of long-range cosmic visitors, asteroids from the Kuiper Belt or beyond. Each crater tells a story, not of destruction, but of adaptation. And in the polar regions, where Titan's lakes cluster like jewels, Cassini saw the most radical transformation of all. Ancient basins, long dry, now partially filled, methane rising, floodplains expanding. Titan's landscape is still becoming. The map we have now is not the final draft. It is a work in progress. But this isn't just geology. This is philosophy written in terrain. Because Titan challenges us to rethink what we mean by activity, by change, by life itself. We've long associated movement with heat, with speed, with volatility, but Titan moves in silence. It evolves not through violence, but through patience. Its rivers don't rush, they wait. Its winds don't howl, they persist. Its changes are not dramatic, they are inevitable. And so, Titan becomes more than a moon. It becomes a mirror to deep time, a reminder that the universe does not measure significance in speed, that some of the most profound transformations happen beneath still skies and across frozen ground. Titan shows us that even in the far reaches of the solar system, even in a place with no sunlight, no warmth, no oxygen, the forces of geology still dance, not loudly, not quickly, but powerfully, elegantly. And through these dances of rain, of river, of wind, and dune, and dust devil comes a whisper. Maybe life doesn't begin with heat. Maybe it begins with motion. And maybe Titan, in its frozen poetry, is already writing the first lines. Life, that fragile, tenacious spark. On Earth, it bloomed in oceans, crawled onto land, and took to the skies. It wrapped itself in water, breathed oxygen, and bathed in sunlight. But what if life never needed any of that? What if somewhere in the dark, in the cold, in the chemical silence, life chose a different path? Titan forces us to ask the most radical question in modern science. Can life exist without water? For decades, astrobiology has been guided by the assumption that life anywhere in the universe must follow the pattern of Earth. Water as solvent, carbon-based molecules, sunlight, or at least geothermal heat, as energy. But Titan shrugs off these assumptions like frost, because Titan's surface has no liquid water, no breathable atmosphere, no sunlight strong enough to feed photosynthesis, and yet it has everything else: cycles, chemistry, complexity. It has clouds, lakes, rivers, it has energy, it has carbon, it has time, and it has methane, a liquid capable of motion, interaction, and change. Scientists once dismissed methane as too inert, too simple, too limited to support life, but Titan changed that. Its methane cycle, rich, dynamic, self-sustaining, mirrors Earth's water cycle so closely that we can no longer ignore the possibility. Could methane be an alternate solvent for life? The implications are staggering. On Earth, water is considered biology's universal solvent. It dissolves nutrients, carries oxygen, supports membranes. It is polar, reactive, versatile. But methane, non-polar, low boiling point, limited solubility, operates under a completely different set of rules. And yet, it works. On Titan, methane doesn't just exist, it behaves. It evaporates, condenses, precipitates. It carves canyons, feeds lakes, and flows through the veins of the moon's surface. It participates in a climate system. It engages in energy exchange. And beyond methane, Titan's atmosphere is a chemical playground. Sunlight, though faint, still reaches the upper layers, where it collides with methane and nitrogen. That spark ignites a cascade of photochemical reactions, forming more complex molecules: acetylene, ethylene, hydrogen cyanide, foundational molecules, building blocks, the very substances that, on Earth, would hint at prebiotic chemistry. These compounds drift downward, collecting in the haze. They fall to the surface in a slow, constant snowfall, an amber rain of tholins, rich organic particles with molecular complexity. Titan is not merely coated in organics, it is soaked in them. And with time, those compounds accumulate, millions of years, billions, quietly, patiently, layering the landscape in the dust of possibility, a chemical compost waiting for a catalyst. But where would life get its spark? Titan's surface is cold, too cold perhaps for complex reactions to occur quickly. But beneath the surface, another world may be waiting. A subsurface ocean, warmed by geothermal heat, rich in water and ammonia. If organic materials from the atmosphere filter down, they could collect in this dark, pressure-rich ocean and evolve. Not life as we know it, not cells, not DNA, but chemical systems capable of replication, adaptation, maybe even evolution, self-organizing reactions, molecular structures that behave like life, even if they aren't alive by our narrow definitions. And perhaps that's the point. Maybe life doesn't have one definition. Maybe it has many. Maybe Earth's biology is just one dialect in a much larger, cosmic language. Because if methane can act like water, if tholins can mimic the richness of carbon chains, if cycles can exist in cold as well as heat, then why not life? Already, theoretical models are emerging. Hypothetical organisms called methanogens, capable of metabolizing methane without oxygen or sunlight. Chemical networks that derive energy from acetylene reactions. Even alternate cell concepts, structures that don't rely on phospholipid membranes, but on exotic compounds like acrylonitrile, stable in methane's cold embrace. In 2015, researchers at Cornell proposed the azotosome, a synthetic cell membrane designed to survive in liquid methane. Their simulations showed it could form, flex, and protect internal chemistry just like a real cell, but born in an alien solvent. Think about that. We have already conceived life forms that could live on Titan, not in the realm of fiction, but in the cold light of possibility. Titan doesn't just allow for this kind of imagination, it demands it. Because every raindrop of methane is a reminder. Water is not the only game in town. Every riverbed etched into ice is a whisper that chemistry does not need warmth to move. Every particle of tholin is a seed. And every season that passes on this frozen moon is a drumbeat echoing toward the future. The question is no longer can methane support life. It's what kind of life might emerge from it. Life without sunlight, life without water, life without fire, but life with motion, with structure, with purpose. Somewhere in the hush of Titan's atmosphere, beneath clouds of hydrocarbon and across lakes of methane, a new form of biology may already be stirring, not loud, not obvious, but quietly assembling itself, molecule by molecule, in the dark. And when we finally recognize it not with our eyes, but with our understanding, we'll realize something earth-shattering. Life was never about the ingredients. It was about the process. And Titan may be where that process is happening right now. They fall like ash from an invisible fire, not born of heat, but of light of ultraviolet sparks igniting chemical symphonies in Titan's upper atmosphere. What falls is not rain, not snow, but something stranger, older, a dust that holds the memory of stars and the whispers of molecules learning to dream. These particles are called tholins, complex, tar-like organics, synthesized when sunlight breaks apart methane and nitrogen in Titan's atmosphere. They form in the skies, dark and fine, suspended in the amber haze, and then, ever so slowly, they descend, a constant chemical snowfall. But this is no ordinary dust. Tholins are rich in carbon chains, aromatic structures, and prebiotic potential. They are not life, but they could be its ingredients, scattered freely across a moon where time moves like a glacier. And over time, they accumulate. Billions of years of falling tholins have coated Titan's surface in a layer of dark, organic soil, flexible, lightweight, molecularly diverse. This dust is Titan's canvas, and it is anything but still. Across vast swaths of equatorial terrain, Titan's winds, though gentle, have shaped this organic dust into colossal dunes. These are not dunes of sand or stone, but of chemistry structures formed from tholins that have fused under pressure, temperature, and time. Cassini's radar mapped them, parallel ridges, stretching for hundreds of kilometers, some as tall as skyscrapers, alien deserts, carved not by heat, but by momentum. These dunes are dynamic, constantly shifting, responding to seasonal winds and atmospheric tides. In Earth's deserts, you hear the wind sing. On Titan, the wind whispers. And still, the dunes move. The process is called sintering, a slow fusion of particles under subtle energy shifts. Under Titan's frigid conditions, Tholin grains don't shatter. They bond. They become flexible, like powdered silk. And this flexibility allows them to travel, to pile, to flow like Earth's sand. But Titan doesn't stop there. From its thick atmosphere come phenomena so strange, so unexpected, they could be ripped from science fiction. Hydrocarbon dust devils. These are vortices, whirling towers of organic dust, born from temperature differences and atmospheric pressure gradients. Spinning across the landscape, they gather fine particles, lift them, and carry them across kilometers. Like silent couriers of the alien biosphere, they deposit tholins in new regions, seeding the surface with the ingredients of possibility. This isn't erosion, this is distribution. Titan's climate isn't just shaping the land, it's spreading its chemistry, blending the old with the new, mixing atmospheric synthesis with geological design. Imagine standing in the middle of this, a frozen plain stretching in every direction, dunes rising like waves in a black ocean. Above you, the golden haze glows faintly, and then, in the distance, a dark spiral begins to rise, a dust devil, slow, silent, carrying the weight of molecules that have never known Earth. And what it leaves behind may matter more than we yet understand. Because Titan isn't just producing tholins, it's layering them, shuffling them, depositing them into new environments. Each layer of dust becomes a record of time, a chemical timeline that tells the story of the moon's seasons, storms, and shifts. The tholins themselves are stable, but complex. They resist breakdown, preserving their structure as they move across Titan's surface. And in the right conditions, they may interact with subsurface materials, methane, ethane, ammonia, triggering reactions we've never observed in the wild. What if a dust devil delivers tholins into a methane stream? What if a dune collapses into a seasonal lake? What if, somewhere beneath this chemical choreography, a reaction begins slow, unassuming, but persistent? That's the haunting question. Is Titan not only mixing its chemistry, but catalyzing it? Dust devils and dunes are more than geological phenomena. They are conductors in a planetary symphony. Each gust of wind is a note. Each drifting particle is a verse. And together, they write a composition that may one day give rise to a biological chorus. And like all great symphonies, it builds slowly, gradually, with movement so subtle, it takes decades to notice. But we've noticed. Cassini observed subtle changes in dune orientation, evidence of seasonal wind shifts. It detected new dust plumes. It recorded thermal anomalies. All signs that Titan's surface is not static, it is evolving. There's a kind of beauty in this contradiction. A moon so cold, it could freeze your blood in seconds. A sky so thick, it hides the stars. A surface so alien, it defies comparison. And yet, it is moving, building, changing, carrying carbon across continents, redistributing molecular wealth, and all of this, driven not by fire, but by stillness. Titan teaches us that complexity does not require chaos, that evolution can whisper, that a world can create without heat, sculpt without water, and transport the ingredients of life without ever needing to burn. In the dunes of tholins and the spirals of dust devils, we see more than chemistry. We see intent, not conscious intent, not design, but the intent of nature to explore every possibility, to experiment in every condition, to write life not once, but in infinite dialects. And if Titan is speaking a new dialect, we must learn to listen differently, because beneath the whirling dust and rising dunes, there may already be a story unfolding, one that began with starlight and methane, and ends with a whisper. Life does not belong to Earth alone. Some worlds wear their history like a scar, On the Moon and Mercury, every crater is a fossilized scream, a memory of violence, frozen in time. But Titan doesn't keep its wounds. It heals them, not with heat or tectonics, but with haze and rain, with time, with patience. On Titan, even impact becomes impermanence. Look closely at Titan's surface, what little we can see through its golden veil, and you'll find something strange, a lack of craters. For a celestial body billions of years old, Titan should be littered with them. It should be a canvas of collisions, meteor strikes, asteroid blasts, interstellar scars. But instead, Cassini saw something else: softened craters, buried basins, features slowly fading into the land. It's not because impacts never happened. They did. Cassini confirmed it. But on Titan, time doesn't preserve violence. It erases it with wind, with methane rain, with sediment made from the sky itself. Titan forgives. There are craters near the equator, long, elliptical scars that hint at shallow-angle impacts, possibly from debris flung off Saturn's own rings or shepherd moons. These craters, stretched and smoothed, look more like memories than wounds. They tell of satellites that struck the moon like skipping stones, grazing, not punching. In contrast, the polar regions show more randomness. Here, the impacts seem deeper, more varied. Some may have come from far-off travelers, Kuiper Belt objects, icy wanderers drawn inward by Saturn's gravity, crashing down through Titan's haze like forgotten messages from the outer dark. But even these craters don't last. Over time, Titan reshapes them. Some are filled with settling tholins, the same organic particles that fall like soft rain from the sky. Others are washed by methane storms, their rims eroded by liquid hydrocarbons flowing in brief, rare floods. Still others are buried by dune migration, swallowed slowly by a creeping desert of carbon dust. It's as though Titan is constantly revising its story, rewriting its surface in long, slow sentences made of erosion and chemical deposition. This act of erasure is not passive. It is active geology, unfolding without heat or tectonics, but with the tools Titan has: atmosphere, gravity, precipitation, and time. Think about that. A moon, without plate tectonics, without volcanic reshaping, still manages to transform itself, not with fire but with weather. And this weather, alien as it is powerful. Titan's dense atmosphere gives its winds strength. Its rains, though infrequent, are deliberate, strong enough to cut into ice, to sculpt channels, to reshape ancient landforms. Over millennia, even the mightiest impact fades beneath a layer of organic silt. Cassini's radar showed evidence of this process in action. Craters once visible in early flybys appeared fainter years later, subtly softened, dusted over, a quiet transformation, unfolding beneath the haze. But it's not just erosion. Titan has layers strata built from eons of organic snowfall and slow weathering. Some craters expose these layers like slices in a cake, a cross-section of Titan's deep time. Each layer a different chapter of its chemical history. And this history is more than geological. It is biochemical. Each impact, each storm, each dust devil stirs the surface, and in doing so, it mixes the prebiotic compounds that fall from the sky. Complex organics formed in the atmosphere drift to the ground. Impacts churn them. Rain spreads them. Winds redistribute them. Over time, Titan's surface becomes not just terrain, but laboratory. Every crater becomes a crucible. Every erosion channel a conduit. Every lakebed a cradle of interaction. And it's not just about where things are, it's about how they move. Titan is dynamic, slow, yes, glacial, but not still. Its surface is in a constant dance between impact and burial, between exposure and erasure. It's a geological game of hide and seek, played over millions of years. But this slow churn may be essential, because where there is movement, there is opportunity for reactions, for contact, for emergence. Even Earth's own history of life began in disturbed places: hydrothermal vents, impact basins, shifting coastlines. Life does not arise from stasis. It arises from interplay. Titan has no continents, no volcanoes, no tectonic drift, but it has this: the long memory of impact and the short memory of surface. It is a world that forgets its wounds not to deny them, but to continue evolving. And perhaps that's the most lifelike thing of all, because what is life, if not the ability to endure change, to integrate it, to be carved by the universe and still become something new? Titan is not dead, it is active in slow motion, a sculpture in progress, a story written in methane and dust, a landscape that heals, not in years, but in epochs. So when we look at its softened craters and ghosted scars, we are not seeing the absence of history. We are seeing the presence of process, and that process may be the very thing that makes any life possible. Some worlds are shaped from the outside, insculpted by impact, eroded by wind, but others are born in the sky. Their surface is merely a reflection of what brews above. On Titan, the atmosphere is not an accessory, it is the architect, the chemist, the first author of the strange story unfolding below. Hovering high above the frozen ground, Titan's atmosphere is unlike anything else in our solar system. Thicker than Earth's, heavier than Mars. Painted in hues of amber and gold, it wraps the moon in a cloak of chemical mystery, a barrier, a canvas, and a laboratory. It is made of 95% nitrogen, just like Earth's. But here, nitrogen is not the language of breath, it is the foundation of alchemy. The remaining 5% is mostly methane, and it is this methane, when struck by ultraviolet light from the distant sun, that ignites a chain of cosmic reactions. Despite being more than 1.4 billion kilometers from the sun, Titan still receives enough UV radiation to fracture methane molecules. That moment of fracture is the spark. From it spills a cascade of interactions, where methane and nitrogen twist into increasingly complex forms. Simple hydrocarbons, acetylene, ethylene, hydrogen cyanide form first, but the reactions do not stop. They climb the molecular ladder, step by delicate step, until they create something darker, heavier, and astonishing: Tholins. These Tholins are not alive, but they are alive with possibility. They form high in the atmosphere, suspended in the haze like stardust, clustering into fine organic aerosols. Eventually, gravity takes hold, and they form a chemical snow, a prebiotic rain, not made of water, not feeding life as we know it, but spreading the ingredients of potential life across the world below. Tholins are the signature of Titan's alchemy. Deep reddish-brown in color, they are the reason Titan appears golden from space. They coat the landscape, settle in the lakes, accumulate in dunes. They are everywhere, and they are not inert. They are reactive, versatile, curious. Their presence is a chemical invitation. On Earth, we have managed to create Tholins in the lab, reproducing Titan's upper atmosphere conditions in vacuum chambers, and watching, in awe, as lifelike molecules assemble from basic gases, amino acids, nucleotide bases, the letters of biology, forming without life. So if these building blocks are raining onto Titan constantly, relentlessly, for billions of years, what are they building? Cassini didn't just confirm their presence. It tracked them. It saw them forming, drifting, settling, and it measured their influence on light, on temperature, on chemistry. Tholins are more than a coating. They are a force, a slow, steady transformation engine. They cool the atmosphere by absorbing sunlight. They drive surface chemistry by altering the reflectivity of the ground. And perhaps, most importantly, they serve as interfaces, points where Titan's atmospheric and geological systems meet. Because Titan's surface and sky are not separate, they are in dialogue. As Tholins fall, they join forces with methane lakes and ammonia ice crusts. They drift into riverbeds. They settle into craters. And there, in the contact zones, they may interact in ways we still can't fully simulate. Cold chemistry, alien reactions, time-driven evolution. The sky is not just above Titan, it is within it. The haze itself is a living archive of transformation. Every molecule in it carries the story of sunlight and shadow, of destruction and creation. And that haze is not uniform. It shifts with the seasons. It thins and thickens. It swirls around the poles and calms at the equator. Titan has weather, yes, but it also has climate, long cycles of chemical fluctuation that alter how the atmosphere behaves. Cassini observed these shifts over a decade. In that time, the haze changed color, density, even altitude. It's a reminder that Titan is not frozen, it's alive with variation. And then, in the uppermost layers, something even stranger happens. At altitudes of over 1,000 kilometers, scientists detected complex ions, large, charged molecules formed from the interactions between solar particles and Titan's upper gases. These ions resemble precursors to amino acids. They are giants in the world of atmospheric chemistry, unusual, massive, and unanticipated. The fact that they exist in Titan's sky suggests that life's raw material doesn't need a surface to begin. It can begin in the air, in light, in collisions. It can begin above. This transforms Titan's atmosphere from a mere gas shell into something more, a reactor, a place where energy and carbon meet under alien conditions to write new chemistry. It's as if the universe, through Titan, is experimenting with alternate origins. On Earth, life began in oceans. On Titan, it might begin in clouds. But perhaps the most profound truth is this: Titan's atmosphere is universal in its behavior, even if alien in its substance. It follows the same physics. It responds to the same forces. It proves that complex chemistry is not rare. It is inevitable, given time and energy and carbon. And if chemistry is inevitable, then life may be inevitable too. The sky of Titan doesn't shine. It glows. It murmurs. It whispers in gold and carbon. And what it whispers is not a warning, nor a secret, but a question. What else is possible when we stop assuming life must look like us? The answer may be falling right now, in flakes of Tholin dust, drifting down onto a lake of methane, settling into a crater, waiting for the next spark. It doesn't fall like snow, not with beauty or silence. It falls like a secret, like a whisper from the edge of chemistry, like the residue of sunlight dreaming in darkness. On Titan, it rains not water, but Tholin's dark, carbon-rich particles born from light and air. They are not life, but they are something just as precious, a possibility waiting to unfold. Every second, high in Titan's upper atmosphere, sunlight collides with methane. These photons, relics from a distant sun, break the bonds of simplicity and unleash a storm of complexity. Methane and nitrogen, once inert, begin a molecular dance. They shatter, they recombine, they evolve. And what emerges from this celestial cauldron is not chaos, but pattern. Simple molecules like acetylene and hydrogen cyanide link together, forming longer chains. These chains tangle, spiral, fold, layer upon layer. They become tholins, complex organic compounds that don't exist naturally on Earth, but may very well be the prologue to life elsewhere. Cassini didn't just detect these tholins. It watched them form, accumulate, and fall, a steady, relentless snow of organics drifting from the sky and settling across Titan's frozen skin. Over millions, billions of years, this slow storm has layered the moon in a blanket of potential. And this potential is everywhere. Tholins give Titan its reddish-brown hue. They shape its dunes. They darken its lakes. They stain its rivers. They mix into methane seas and crust into impact basins. They are the pigment of the unknown, painted over every corner of the moon's face. But they are more than decoration. They are molecular treasure chests. On Earth, when scientists reproduced Titan's atmospheric conditions in labs, the resulting tholins contained amino acid precursors, chemical ancestors of life. They showed that sunlight alone, given the right gases, could spark the first embers of biology. Now imagine that happening for eons, planet-wide, under the golden haze of Titan's sky. Not in a flask, not in a vacuum chamber, but in the wild. On a global scale, Titan is not dabbling in chemistry. It is immersed in it. Its surface is soaked in organic fallout. Every dune, every drop of rain, every gust of wind becomes a vessel for prebiotic transport. This is not a passive environment. It is an active laboratory, scaled to a planetary level. And this laboratory is rich in interaction zones. Where tholins fall into methane lakes, new reactions may ignite. Where they settle into ammonia-rich soil, new compounds may emerge. Where they accumulate in impact craters, compressed by eons of snowfall and weather, stranger molecules might already be forming molecules that mimic life, or maybe even begin it. What's haunting is not that tholins are present, it's that they're ubiquitous. They are not rare anomalies, they are the default, the background noise of Titan's entire system, which means Titan is not a place where life might be sparked by some lucky accident. It is a place where conditions conspire to make life likely, and perhaps inevitable. Tholins resist simple classification. They are not alive, but they are not dead. They are not reactive like water, but they are not inert like stone. They are liminal matter caught between simplicity and complexity, between randomness and order. Some researchers suggest they are polymeric, capable of forming chain-like structures, akin to biological macromolecules. Others suspect they may function like scaffolds, providing structure and stability for more reactive compounds to build upon. And if that is true, then Titan's surface may be filled with molecular frameworks, the skeletons of a biology yet to be born. Because what matters most isn't that Titan has organics, it's that it has processes. A constant rain, a constant deposit, a constant redistribution by winds, lakes, and storms. This isn't a static planet, it is a moving system, powered by chemistry and time. And time is the crucial ingredient. On Earth, it took hundreds of millions of years for life to appear after the formation of oceans. But Titan has had liquid methane and Tholin snowfall for potentially just as long. So what might it have built slowly, quietly, invisibly in its golden twilight? Somewhere on Titan, a pool of methane may already contain complex chains floating in solution. Some molecule may have learned to fold, to replicate, to persist, maybe not in a way we'd call alive yet, but in a way that makes the line between life and chemistry hard to see. Maybe what we call prebiotic is just a phase. Maybe Titan has already passed it, and what we call tholins mere dust may be the foundation of something extraordinary. In the endless amber dusk, under clouds that never clear, on shores that glisten with alien seas, Titan gathers its secrets grain by grain. It doesn't shout them, it accumulates them. And maybe, if we listen closely enough, we'll realize Titan doesn't need to evolve Earth's biology. It's building its own. We've been watching the sky, tracing clouds of methane, following dust devils and hydrocarbon rains, but Titan hides its greatest secret not above, but below. Beneath the frozen surface, under dunes and lakes and layers of tholins, lies something ancient, quiet, and unimaginably important, a hidden ocean. And not just any ocean, a dark subsurface sea, made not of methane, but of water and ammonia, a forbidden warmth beneath the coldest mask in the solar system. For years, scientists suspected Titan's surface was not the whole story. The gravity was too soft, the shape too flexible. Something deep beneath was moving, subtly shifting the crust. And then came the proof. Cassini's instruments, radar echoes, gravity measurements, magnetic field fluctuations began to paint a new picture. Titan's ice shell, once thought solid and static, was floating atop a liquid interior, a global ocean, stretching for thousands of kilometers, encased in ice as thick as a mountain range. But this wasn't a warm tropical sea. It was something far stranger. It was a mixture of water and ammonia, a cryogenic cocktail that remains liquid even at negative 180 degrees Celsius, negative 292 degrees Fahrenheit. Ammonia lowers water's freezing point, acting like an antifreeze in Titan's planetary veins. The result? A supercooled, salty, pressurized ocean, locked beneath up to 100 kilometers of frozen crust. This ocean is not a passive reservoir. It may be dynamic, churning slowly, creating internal pressure, causing cracks, fissures, and possibly even eruptions at the surface. Cassini hinted at this with strange bulges in terrain, shifting crustal features, and thermal anomalies that couldn't be explained by surface weather alone. Titan, it turns out, is not solid. It is layered. It breathes from within. And between the icy shell and the dark ocean lies a third, stranger layer, a crystalline structure known as a clathrate hydrate. Clathrates are cages of water ice that trap gas molecules inside them, mostly methane in Titan's case. This 5 to 10 kilometers thick layer acts like a thermal and chemical membrane, allowing some materials to pass while trapping others. It is both a barrier and a bridge. And through this clathrate shell, Titan's surface and subsurface may be exchanging materials, slowly, gently, but enough to matter, enough for chemistry to spread. Imagine Tholins drifting down from the sky, collecting on the surface for eons. Now imagine that material, organic-rich, prebiotic, being drawn downward through cracks or carried into the subsurface by methane infiltration. What happens when it reaches the ocean? A place with pressure, energy gradients, liquid water, and possibly even geothermal heat. This is where the story becomes not just interesting, but profound. Because on Earth, some of the oldest, most resilient forms of life are found at the bottom of oceans, clustered around hydrothermal vents. There, in the absence of sunlight, life thrives feeding on chemicals, metabolizing minerals, adapting to pressure and darkness. What if Titan is a mirror of that? Not an ocean of warmth, but one of possibility. Not illuminated by the sun, but by chemistry itself. Some models suggest that Titan's clathrate layer may rupture from time to time, releasing methane geysers or even fluidic eruptions. Surface features like Sotra Patera, a massive dome-like depression, may be cryovolcanoes, cold volcanoes that don't spit lava, but water-ammonia mixtures. These features hint at a circulating system, a planetary loop that connects the organic-laden sky with the chemically rich ocean beneath, a loop that has likely been running for millions, if not billions, of years. And time, once again, is everything. If Titan's ocean has been collecting, storing, and reacting with organic material for geological epochs, then it becomes not just a subsurface sea, but a chemical incubator, stable, isolated, slow-burning, the perfect place for something to begin. Not life as we know it, not even close, but organization, reactivity, evolution in the dark. Maybe it starts with molecular scaffolds, long carbon chains curling into spirals. Then comes feedback molecules that replicate, that mutate, that survive better than their neighbors. Then, over millions of cycles, comes a system. Not a cell, not yet, but a chemical network, a pre-life state where complexity self-replicates, where molecules explore their own longevity. And maybe, right now, that very process is still unfolding, somewhere beneath 50 kilometers of ice, waiting, learning, becoming. What Titan offers is not certainty, it offers hope grounded in physics. The ocean is real, the organics are real, the energy gradients are real, the timescale is vast. And when we line those facts up, no matter how conservatively we reach a conclusion we can no longer dismiss. Titan has the ingredients. Titan has the structure. Titan has the time. It may not yet have life, but it may already be walking the path toward it. And that changes everything. Because for the first time, we are not looking for aliens among the stars. We're not dreaming of civilizations light years away. We're looking beneath the ice of a moon in our own solar system and finding something that behaves like a beginning. On Earth, life clings to water like breath to lungs. Every cell swims in it. Every gene depends on it. But what if life doesn't need water at all? What if, in the icy shadows of Titan, something entirely different is forming, something not made of familiar biology, but of new architecture, new rules, and a new kind of resilience? To imagine life without water is to unmoor ourselves from the only model we've ever known. On Earth, cell membranes, the structural gatekeepers of all life, are made of phospholipids. These molecules self-assemble into bilayered skins, flexible and dynamic. able to hold in life's machinery while communicating with the world outside. But they require water to function. They rely on water's polarity, its hydrogen bonds, its unique behavior as a solvent. So when we look at Titan, a world where water is locked in ice, and the dominant liquid is methane, a non-polar, cryogenic fluid, our instincts say, life can't happen here. But instincts are Earth's prison. Science, however, has other ideas. In 2015, a team at Cornell University asked a radical question. What if Titan's alien chemistry could give rise to a new kind of cell? Their answer was a theoretical structure called the azotosome, named from azote, an old word for nitrogen. Azotosomes are cell-like membranes made not of phospholipids, but of acrylonitrile, an organic compound discovered in Titan's atmosphere by Cassini. In Earth terms, acrylonitrile is toxic, but on Titan bathed in methane, chilled to -180 degrees Celsius, it behaves differently. Simulations showed that these molecules could self-assemble in liquid methane, forming stable, flexible, and permeable structures just like Earth cells. Let that sink in. Not only could these alien membranes form under Titan's conditions, they could flex, hold pressure, and protect internal chemistry, the exact behaviors life's containers must perform. The azotosome was a revelation, not because it proved life exists on Titan, but because it proved life could exist differently. In methane, in cold, in total darkness, these hypothetical structures don't dissolve like lipids in oil, they persist. They could, in theory, harbor complex chemistry reactions fueled not by heat or light, but by the slow dance of carbon and nitrogen in a cryogenic sea. Cassini gave us more than just acrylonitrile. It detected hydrogen cyanide, acetylene, propane, a chemical toolbox ripe for reaction. If these ingredients encounter one another within azotosome structures protected, contained, and repeated over time, then the door opens not to traditional biology, but to alien biochemistry. Not DNA, not proteins, but something else, something we haven't named yet. Earth's life began in water, because that's what we had. But the cosmos is not limited to our fortune. Titan may be the universe's counter-argument. It may be trying to show us that the boundary of life isn't liquid water, it's organization, it's structure, it's the ability of matter to hold, repeat, and evolve. And azotosomes, though theoretical, prove that structure is possible. Now picture this: methane lakes, dusted with tholins, absorbing molecules from the atmosphere, drifting across time. Inside, membranes begin to form, not en masse, not all at once, but sporadically, at first, then again and again. Each time, they last a little longer, protect a few more molecules, allow a few more interactions. Then, maybe one day something replicates. Not life as we know it, but life as it could be. What begins as structure becomes process. What begins as chemistry becomes history. This idea isn't fiction. It's on the cutting edge of astrobiology, systems, chemistry, and cryogenic modeling. And it's all rooted in data, in what Cassini saw, in what Titan gives. We once believed the cell was the unshakable foundation of life, but now we're beginning to see it for what it truly is: a strategy. Not unique, just effective. And strategies can vary, especially in a universe as imaginative as ours. The real gift of the azotosome isn't its structure, it's its challenge. It dares us to expand our definitions, to abandon water worship, to see that biology is not defined by its ingredients, but by its pattern of persistence. In Titan's lakes, there may be no green algae, no fish, no flagella, but there may be organization, there may be evolution, there may be becoming. And if that's true, if even one azotosome-like entity has crossed the line from molecule to process, then Titan is no longer just a moon. It is a second Genesis, one written not in Earth's script, but in the alien calligraphy of cold chemistry and cosmic patience. And when we finally reach beneath those methane waves, when we touch that shadowed biology, we won't just be discovering life. We'll be discovering what life means. We came to Titan with instruments, probes, equations, expectations. We came searching for familiarity in a world that promised strangeness, and what we found was more than data. We found a mirror held up not to our planet, but to our assumptions. And now, as we stand on the edge of understanding, the question is no longer, is there life on Titan? The question is, are we ready to recognize it when it looks nothing like us? Titan does not fit our definitions. It laughs in the face of Earth-centric thinking. It presents lakes with no water, membranes with no lipids, clouds without sunlight, an ocean with no warmth. It builds storms from methane, deserts from organics, and rain from gases that would explode on Earth. And yet it works. It functions, it cycles, it evolves, not quickly, not loudly, but profoundly. It whispers of processes so alien, yet so orderly, that they blur the line between geology and biology. Its atmosphere brews molecules that, on Earth, only form under the guidance of life. Its surface gathers them, its subsurface may stir them, and its time immense, unhurried, and patient may be the silent architect of something unthinkable. And that brings us to the final paradox. We've been looking for life as we know it, but Titan might be offering us life as it could be. Not cells and genes, not oxygen and chlorophyll, but function, feedback, resilience. Titan may already host chemical systems capable of adaptation, self-replicating networks, membrane-bound reactions, engines of entropy reversal in a sea of liquid methane. No DNA, no water, just organization in the dark. Could we recognize it? Or would we overlook it, dismiss it as too slow, too cold, too strange? Would we miss the subtle signals because they don't scream life in Earth's accent? Because life on Titan, if it exists, would not announce itself. It would endure. It would evolve in silence. It would bloom in twilight. It would hide in plain sight, beneath a haze of golden chemistry. And if our probes descend, if they sample the lakes, the dunes, the cryovolcanoes, and they detect something moving, repeating, reacting, what then? Will we know what we're seeing? We must prepare ourselves for a new definition, because life may not be rare in the cosmos. It may simply be diverse beyond our imagination. It may not need Earth's warmth, its light, its breath. It may only need rules. Rules that Titan follows with unwavering fidelity. Cassini has left us clues: organic complexity, atmospheric synthesis, lakes of energy-rich solvents, a subsurface ocean of potential, membrane analogues, molecular precursors, and time, billions of years of time. These are not scattered coincidences. They are a pattern that points to life. Not Earth life, not even proto-life, but something else entirely: exo-life, cryo-life, alien life. And if we find it, we will be forced to rethink everything. Not just what life is, but where it belongs. Not just how life works, but why it emerges at all. Because if life can exist in the methane lakes of Titan, it can exist in 1,000 other places, in the icy moons of Jupiter, in the cloud decks of Venus, in the subsurface oceans of exoplanets orbiting red dwarfs. Life becomes not a fluke, but a feature of the universe, an emergent phenomenon of chemistry under constraint, a law, not a miracle. But that future depends on one thing: our willingness to see without prejudice, to walk onto Titan's alien shore and ask, not, does this resemble Earth? But, is this self-sustaining? Is this complex? Is this becoming something more? Because the real discovery isn't life, it's the expansion of our consciousness. The day we recognize alien life in its true form, unfamiliar, unrelatable, yet utterly real, is the day we become not just explorers of space, but students of the cosmos. Titan offers us this gift, but only if we are ready to accept it. So we end not with an answer, but a question. What if the greatest barrier to discovering life is our definition of it? In the far reaches of the solar system, beneath a golden sky and frozen crust, there may be something stirring, not in sunlight, but in shadows, not in oceans, but in lakes of liquid methane, not in cells, but in networks, Not in water, but in will. Titan doesn't need to look like Earth to matter. It only needs to prove that life is not unique to us. And if we listen carefully enough, if we open our eyes, not just as scientists but as witnesses, we may finally see it. Life has already begun, just not in a form we expected.